Welcome. So, have you ever looked at a modern AI application, a chatbot or some creative tool, and wondered how did they actually build that? Well, you are in exactly the right place. Today, we're going to pull back the curtain on the whole process. We're looking at this really brilliant new approach called AI engineering, and we'll walk through the step-by-step playbook that developers are using right now.
Okay, let's just dive right in, because the game has totally changed. See, in the old days, building with AI meant you spent months, sometimes even years, just gathering huge amounts of data and training a model from scratch. The actual product, that was way down the line. But today, the script has completely flipped. We've got these powerful foundation models that are ready to go. So now, it's all about starting with a great product idea and just adapting an existing model to do what you need. And that means you can iterate and improve things incredibly fast.
So, here's the journey we're going to take. First, we'll talk about this big picture shift in how AI gets made. Then, we'll walk through the key techniques developers use to kind of shape what a model can do. And finally, and this is so important, we'll get into the biggest piece of the puzzle. How do you even measure and make sure the quality is there? So what is this new paradigm really all about? Well, it's a huge shift in how we think. We've moved away from the super difficult task of building models from the ground up to the much more creative and accessible job of building amazing applications on top of them. And this right here is the core idea of AI engineering. Instead of burning months of time and, millions of dollars training a model, AI engineering is really the art and science of taking these powerful pre-existing models and adapting them for your specific use case. It's faster, it's cheaper, and honestly, it's opened the floodgates for a whole new wave of innovation. Okay, so you're a developer. Where do you actually start? Well, the journey begins with the simplest, most accessible tool in the toolbox. This is always the first lever you pull. And that tool is your first and most essential one, prompt engineering. The best way to think about it is like you're giving a super smart assistant very clear, very specific instructions. Seriously, the better your instructions, the better the result you're going to get. You can give it a role, like act as a travel agent, or tell it what format to use, or even show it a few examples of a perfect answer. Now, prompting is incredibly powerful, but it has a really clear limit. What happens if you ask a model about something that just happened yesterday, or about your company's private data, or really anything that wasn't in its original training data? Well, it just won't know the answer. It basically hits a knowledge wall. So how do we get around that knowledge gap? It's actually a pretty cool idea. If the model doesn't have the book it needs to read, well, we just give it a whole library to pull from. We connect it to live external sources of information. The technical name for this is RAG, which stands for Retrieval-Augmented Generation. Here's how it works. Before the model even tries to answer your question, it first retrieves relevant info from an outside source. That could be your company's internal wiki or a live newsfeed. Then, it uses that information to augment or improve its response. This is how you give a model knowledge about things it was never trained on.
All right, so now we're facing a totally different, much more subtle problem. Thanks to RAG, our model has all the right facts. Great. But what if its answer is in the wrong format? Or the tone is just completely off? Or maybe it isn't following a really complex instruction, or worst case, it's generating unsafe content. The information is right, but the behavior is wrong.
To fix these deeper behavioral issues, we need a much more powerful technique. We can't just feed it more information when we ask a question. We have to actually go in and change how the model itself works. And that technique is called fine-tuning. It's kind of like sending that super smart assistant back to school, but for a very specialized course. You give it a carefully curated dataset, maybe hundreds or thousands of perfect examples of the exact behavior you want to see. By training on those examples, the model literally updates its internal programming and learns a new skill or a new style or a whole new way of thinking. So if we put this all together, these techniques really form a logical workflow. You always start with the simplest, cheapest option, which is prompting. If that doesn't get you where you need to be, because the model is missing information, you add RAG. And then, if the model's core behavior is the problem, that's when you move to the more complex and expensive step of fine-tuning. But here's what's really interesting. In the real world, this whole process is rarely just a straight line. It's much more like a flowchart. You might find that your simple RAG system needs an upgrade to something more advanced. Or maybe our problem has nothing to do with knowledge gaps, so you skip RAG entirely and go right from prompting to fine-tuning. The right path is always figured out by analyzing why your app is failing and then picking the right tool for that specific problem.
But hold on. How do you make any of these decisions? How do you even know if your new prompt is better than the old one, or if your RAG system is actually helping? And that brings us to what is, without a doubt, the most critical and often the hardest part of this entire process: evaluation. This is honestly one of the biggest open challenges in AI engineering today. Think about it. With traditional software, code either works or it doesn't, right? But with generative AI, there's not just one correct answer. How do you put a number on creativity, or helpfulness, or relevance? It's tough.
The challenge really comes from the fact that these models are so open-ended. For any single question you ask, there could be countless valid responses. So you can't just make a simple answer key and check the model's work against it. This makes measuring improvements, and just as importantly, preventing things from getting worse, incredibly complex. It's why developers spend so much time building really solid evaluation systems.
And the main takeaway here, the thing to really remember, is that evaluation isn't something you just tack on at the end. It's a constant, continuous process that guides every single decision you make along the way. You evaluate to pick your base model, you evaluate to improve your prompts, you evaluate to test your RAG system, and you evaluate to see if your fine-tuning worked. Without constant evaluation, you're just flying blind.
So this table is a really great way to sum up the two big guns in our toolkit. You use RAG when the model needs to know things it wasn't trained on. And you use fine-tuning when the model knows the facts, but it doesn't know how to act the way your app needs it to. One changes the context, the other changes the model itself.
And please remember, these are not mutually exclusive choices. Not at all. The most sophisticated, highest-performing AI apps out there, they often use a powerful combination of all three. They'll have masterful prompt engineering, a RAG system that pulls in real-time data, and a fine-tuned model that is perfectly adapted for its job. They all work together.
So this systematic workflow, starting with prompting, moving to RAG, then to fine-tuning, all of it guided by constant evaluation, that's really the key takeaway for how we build with AI today. But it also leaves us with a much bigger question for the future. As we get better and better at building these incredibly powerful applications, the next real frontier is going to be about making sure they're reliable, safe, and ultimately that they're trustworthy for every single person who uses them.